Welcome to the second lectures of chapter 2. In this lectures, we will talk about temperatures and volume. So, what is temperature? Temperatures is a measures of the hotness or coldness of an object. Temperatures is a physical property that determine the direction of heat flow. Heat always flows from a substance at higher temperature to one at lower temperatures. So when you touch a hot object and you feel hot, that means the object is a higher temperature than our hand. So in science, especially physics and chemistry, there are two most common units of temperatures. One is Celsius and second is Kelvin. Okay, we don't use Fahrenheit in science. Okay, either Celsius or Kelvin. Celsius scale was originally based on the assessment of 0 °C is the freezing point of water and 100 °C is the boiling point of water at sea level. Kelvin. Kelvin temperatures is the SI unit of temperature. So 0 on the Kelvin scale is the temperatures as quick or thermal motion ceases. A temperature refers to a absolute zero, and 0 Kelvin doesn't exist. Kelvin is based on the properties of gas. There is no negative Kelvin temperature. So, and how do we convert? How do we relate Kelvin and Celsius? So, if you want convert Celsius to Kelvin, you took Celsius degree plus 273.15. If you want convert Kelvin to Celsius, then Kelvin minus 273.15. Keep in mind, the Celsius and Kelvin scales have equal size unit. That means a Kelvin is the same size as a degree in Celsius. Now, okay, so here is how you convert between Kelvin and Celsius degree. So if we're looking at the freezing temperatures of water in Celsius, this is 0 °C. Convert to Kelvin, 0 plus 273.15 is 273.15 Kelvin. Boiling point of water is 100 °C. Convert to Kelvin, it will equal 373.15 Kelvin. And the change in temperatures is the same. So in Celsius, the change in temperatures is 100-degree interval, and in Kelvin, the change in temperatures is also 100-degree interval. So that's why I said the size of a degree on the Celsius scale is the same as the size of a degree on the Kelvin scale. So that is temperatures in chemistry and physics. Now, next we're going to talk about volume. Volume is not a base unit for SI. It is a derived unit. A derived unit is obtained by multiplies or division of one or more of the base unit. So volume is derived from length. Now, if you remember geometry and what you learned in high school, so if you have a cube, right, that means all side of the cube is equal, okay? And that side equal A, and the volume of that cube is A raised to the power of 3. So if the side of that cube is 1 meter, okay, A equal 1 meters, then the volume of that cube is 1 meters raised to the power of 3 equal 1 meter times 1 meter times 1 meters equals 1 meters raised to the power of 3 or 1 cubic meter. Okay. The same goes for if you have a cube and its side is 1 centimeter, then the V of this cube is 1 cubic centimeter. Okay? And of course, you also have 1 cubic decimeter. So, and remember, 1 milliliters will equals 1 cubic centimeters. And sometimes in the health professional field, they're going to say, okay, this is 1 cc. And again, if you remember from the metric system, 1 liters will equal 1000 milliliters. So, and 1 milliliters equal 1 cubic centimeter. Then 1 liter is also equal 1000 cubic centimeter. Okay. Now let's do a little bit of a practice problems here. So what is the equivalent statement when you want to convert cubic decimeter to cubic meter? Okay. So remember, 1 cubic meters is the volume of a cube whose size is 1 meter. Then 1 cubic 1 cubic decimeters is the volume of a cube whose size is 1 decimeter. Okay, and size of a cube is A equal 1 decimeter. Volume of this cube equal A raised to the powers of 3 equal 1 decimeters raised to the powers of 3 equal 1 cubic decimeter. Okay. Now, but in the previous lectures, we learned about prefix. 1 decimeter equal 10 raised to the powers of negative 1 meter. It's also equal 0.1 meter, right? So instead of saying the size of this cube is 1 decimeter, I can say the size of this cube is 0.1 meter. Now, the size of this cube, A, equal 0.1 meter, and I will do the same. Volume of this cube equal A raised to the powers of 3 equal 0.1 meter raised to the power of 3. So 0.1 meter, right, times 0.1 meter times 0.1 meters. Volume of this cube will equal 0.001 cubic meter. Okay, so from these workout, we can conclude 1 cubic decimeter equal 0.001 cubic meters or 1 times 10 raised to the powers of negative 3 cubic meter. Okay, and this is your answers. Okay. Now, next, what is the equivalent statement if you want to convert cubic meter to cubic centimeter? Okay. Same thing. And let me duplicate the slide. Okay. Now, part B. So, 1 cubic meters is the volume of a cube whose size is 1 meter. That, right? So from the previous slide, so if the size of this cube is 1 meter, okay, then the volume of this cube is A raised to the powers of 3 equal 1 meters raised to the powers of 3 equal 1 cubic meter. Right. But from the previous video, when we talk about prefix, compare meter to centi. So 1 meters will equal 100 centimeter, right? Because it's to 10 raised to the powers of 2. So now, instead of saying this cube have a size of 1 meter, I can say this cube have whose size equal 100 centimeter. And then volume of this cube still equal A raised to the powers of 3. But now 100 centimeters raised to the powers of 3. Okay, so 100 times 100 times 100. Okay, so the volume of this cube will equal 1 times 10 raised to the powers of 6 cubic centimeter. So from the workout so far, we can conclude 1 cubic meters equal 1 times 10 raised to the powers of 6 cubic centimeter. Okay. And now, how can we measure volume? So there are many ways that you can use, there's many methods that you can use to measure volume. So you can use graduate cylinder, syringe, or a burette. This has graduations or marking for volume. If you want to measure a specific volume and want to achieve a more accurate, you can use pipette, okay, to deliver a specific volume, or you can use a volumetric flask, and volumetric flask will hold a specific volume. And pipette and volumetric flask, they has one specific marking for volume. Okay, now let's talk about a little bit of volume and let's expand that a little bit. So if you have a cube, because the cube's all side is equal, okay, say A, then volume of that cube will be A raised to the power of 3. What if you have a rectangular box and the side is different? For example, if you have a, let's just say, rectangular box and you have a length, let's say equal 10 centimeters, a width 8 centimeters, and a height is 5 centimeters, how can you find the volume of this box? So volume of the box, or if you know the length, the height, and the width of any box, then the volume of that box equals length times width times height. Okay, because the cube, its size is volume, so the length equal the width equal the height, so A raised to the powers of 3. Okay, but because the size of the box might not be equal, so length times width times height. In fact, you can calculate the volume of any shape using this formulas. Volume will equals the areas of the base of that shape times the height. Okay, this is true when you calculate the volume of the spheres and the volume of the cylinder. Okay, that's for volume. Now let's talk a little bit about the math and the exponential. Okay, so volume, okay, cubed. So if you have A times A times A, okay, this is A raised to the powers of 3. What if you have A raised to the powers of 2 times A raised to the powers of 3. This equal A raised to the powers of 5, or A raised to the powers of 2 plus 3. Okay. If you have A raised to the powers of 6 divided by A raised to the powers of 2, this equal A raised to the powers of 4, or A raised to the powers of 6 minus 2. Okay, so when you multiply together and you share the same base, you add the exponential together. When you divide and you have the same base, okay, A raised to the power of 6 divided by A raised to the power of 2, you subtract the exponential, okay? And let's generalize. So if you have A raised to the power of 6 of x times A raised to the powers of y, then A equal A raised to the powers of x plus y. A raised to the powers of x divided by A raised to the powers of y equal A raised to the powers of x minus y. Okay. Last but not least, if you have 10 raised to the powers of negative 2, you can write this A equal 1 over 10 raised to the powers of 2. Okay, think about it, right? So this gonna be equals 1 divided by 100 equals 0.01. Okay, and that's my last key point for you to remember. So if you have A raised to the powers of negative x, it will equal 1 over A raised to the power of x. Why the exponential thing is important? Because later when you involve like large numbers and smaller numbers like Avogadro numbers, or when you involve like nanometer, nanoseconds, the tip about exponential will come in useful. Okay, that is for temperatures and volume, and I will see you in the next lecture.